Okay guys, just welcome to Let's Get to the Marks. Just going to do a quick little video on hydrogen fuel cells. So we have an anode and a cathode, which are electrodes in the hydrogen fuel cell, different to electrolysis. We've got hydrogen coming in at one end, we've got oxygen coming in at the other end. Hydrogen's the fuel. You can use other fuels, but hydrogen is the fuel of choice for most of these fuel cells. Hydrogen releases its electrons, and these then travel through the circuit. In this case, there's a light bulb, a lamp, symbol of a lamp there. They're operating that, but it could be the motor of a car. When the hydrogen loses electrons, it becomes hydrogen ions, H+, and the electrolyte is in the middle of this fuel cell. Oxygen enters from the other side. The oxygen moves down and picks up the electrons. So the oxygen is itself reduced, it's gaining electrons. And the oxygen then combines with those electrons and the hydrogen ions to make water. Water is the only major waste product in a hydrogen fuel cell, and this is the overall equation for hydrogen fuel cells. So two hydrogen molecules plus an oxygen molecule, both in the gaseous state or both as gases, form two water molecules. Now we can break that down into two half equations. So coming in from the left of our fuel cell, a hydrogen molecule splits into two hydrogen ions and releases two electrons. Those are the electrons that power the car, the motor, the engine, the lamp in this case. As they come down the other side, the other electrode, they combine with four hydrogen ions. We have four electrons, four hydrogen ions, and one oxygen molecule to make water. If we combine these two half equations, the one from the left, the one from the right, we make the overall equation you see at the bottom there. So, yeah, you need to know those half equations for the hydrogen fuel cell. So hydrogen's the fuel and it's supplying the electrons. It's not being burnt. It's not being combusted. You might think, oh, it's combustion, hydrogen burning in oxygen. We can do that, but that's not what we do in a hydrogen fuel cell. Now, the positive aspects of hydrogen fuel cells is that water is the major waste product, H2O, and that's a pretty good waste product. There's no carbon dioxide emissions, so there's no greenhouse gases being released, no toxic waste like lithium and stuff from batteries. Now, the negatives, and they're also very efficient hydrogen fuel cells. The negatives are that storing gases is difficult. Hydrogen's a gas. You got to compress it into a liquid, which is a real pain, and that's expensive. And hydrogen can be dangerous. Storing gases is dangerous. Sometimes we have to use electrolysis to get a source of hydrogen. Where do we get hydrogen from? We can split water, but that uses a lot of energy, which could release carbon dioxide. Where are we getting the electricity from? The other source of hydrogen is by cracking alkanes like C2H6, that's ethane, and that's going to use up fossil fuels. So we can crack them, passing them over, vaporizing them and passing them over aluminium oxide catalyst to make hydrogen and ethene in this case. So there's lots of negatives for hydrogen fuel cells. They're not as clean as we first appear. The reaction between hydrogen and oxygen in a fuel cell was used to produce electricity. That's the electrons we saw going up through the lamp. Hydrogen fuel cells and rechargeable cells are used to power some cars, give two advantages. So what were two of the advantages of the hydrogen fuel cells? Again, we got to think about this. You can pause the video if you want, but they don't make toxic materials like you get in batteries. In batteries, you get things like lithium and toxic waste metals. They're also highly efficient and they don't need recharging. As long as you have a constant supply of hydrogen and oxygen, you don't need to recharge your hydrogen fuel cell. So you can travel further. Now, it asks you to write a half equation for one of the reactions. So you just got to remember the two half equations from the previous slide. So we got H2 goes to 2H plus and plus 2E minus, or we've got the oxygen plus the 4H plus 4 electrons goes to 2H2O. They're the two main half equations in the hydrogen fuel cell. Now this is another half equation, a little bit different, and it's asking you to balance it. Essentially, it's just a balancing job. So we've got three hydrogens on the left. We need to sort that out. So let's put a 2 in front of OH minus, and that makes us have 4 hydrogens and 2 oxygens, a lot easier to balance. We now put a 2 in front of the water, and we need to put a 2 in front of the E minus to balance the negative charge of the hydroxides and the electrons. Why is the fuel cell in question described as an alkaline fuel cell? Well, it uses hydroxide ions. That's the OH minus ion. And hydroxides are what makes things alkaline. Let's get to the marks.